Hi everyone, welcome to our first online session for the Foundations of R course using statistics. And just wanted to welcome you here. It looks like that we have a very large crowd signed up for today's session, so that's great. This is an opportunity for us to get to know each other a little bit and also to develop our competencies and skills using R. So the part of the session will be hands-on. So I wanted to welcome you. My name is Kristen Sosulski. I'm your professor for the R portion of this course. I hope you can see me and hear me, but we're going to pause for a second and we're going to make sure that everybody can kind of hear and also see what's going on the screen. So at this point, I'm just going to move to the next slide. And so I just want to make sure that we can all hear. So a few things here. Now, I'd like you to make sure that your microphones are muted. And I've taken the liberty to already mute your microphones, but I prefer a more democratic classroom. So I'm going to unmute everyone, and I'm going to ask you to actually mute yourself by pressing the microphone icon and muting yourself. So I see a bunch of you are doing that already. That's great. If we do hear feedback during the class, I'll go ahead and mute you, but just be aware that if you're dialing in or if you are on the computer, that that the microphone is muted. Thank you. The next thing is that during this session, we'll of course be using the microphone to talk and ask questions and introduce ourselves. But I also want to just make sure that we have another channel to communicate, which is going to be our chat. So if you can hear what I'm saying, please just type in the text chat yes. And you can find the text chat window just under chat. Thank you, Stephanie, Caesar, Marlene, Anna, Brock. So I can see everyone participating. That's great. So we're going to use this as one way to communicate in this course. I like to kind of think of this as the back channel of the course. Feel free to send me messages directly. So instead of saying to the entire audience, you can choose here my name, or if you wanted to send it to a classmate, that's totally fine. It's kind of like the equivalent of passing notes in class. But I also think of it kind of as our little mini Twitter feed for the course, highlighting things, asking questions. Anytime if I need to write a little code, I'll show it in the text chat as well. And as we are practicing solving problems using R as a tool, I'm going to ask you to cut and paste your answers here. So it'll only be like one line of code. So I'm not going to ask you to cut and paste entire programs, but just really as a way to kind of show me that you're participating, but also share with others the ways that you solve the problem that I posed. And you'll notice that there are going to be, alternative solutions to how we can solve problems in R. There's not just one way all the time. So great. So some of you who are not on the web version of GoToTraining will be able to use your camera. And I'm just like checking out the list now. It looks like a few people have the ability to use a camera. So if you have a camera icon next to your name, you can feel free to turn that on, and I'll give you permission to use your camera as part of this course if you like. So I'm doing that right now with a few people. I think like Marlene and Matthew and Jerome, I see that you have a camera icon next to your name. So if you decide to show your face, it's always great to put a face with a name. Thanks, Jerome. Nice to see you. So it's just us two up there, right? Okay, thanks. Thanks, Matthew, for not leaving us up here alone. So I have to actually go ahead and enable everyone individually, so just taking me a minute. But feel free to enable your webcam. Make sure you're comfortable with your image and your background and the lighting, so we can all see each other. Okay, so I'm going ahead and just making sure that everybody who has the ability to share a webcam can. If you can't, just send me a chat in the chat window. Great. And this is just like a reminder that if you can't hear, you're not going to be able to hear what I'm saying, but at least you'll be able to read this. Want to make sure that your speakers are turned on, your volume is raised. And if you've dialed in instead of using voice over IP, just make sure to mute your phone just as an extra way not to have that kind of static or interference. Great. So thank you, those. Share your camera. Feel free to turn them on and off whenever you like. About halfway through, I'll turn mine off because I think it will just be distracting. But for now, it's kind of nice to put faces with names. And the purpose of today's session, we have 3 sessions that you'll be attending. So this one is covering lessons or chapters 1 and 2 as part of the course. And by this time, hopefully you've gone through and you've completed those lessons and maybe even the homework. But it's also a way for us to kind of get to know each other. I feel very fortunate that I'm one of the faculty that get to kind of greet you, whether it's not in person, but virtually to the MSBA program. And this is also an opportunity for you to get to know some other people that are in this class. We have a pretty big group today, but I'm going to try to be ambitious and have all of us introduce ourselves just even briefly. And then I want to provide you with an opportunity to practice R in real time and also have the benefit of me giving you in a live format a basic overview of R. Some of you may be new to this, and I want to learn kind of a little bit more about what you already know and what you're looking to learn. And as always, feel free to ask questions throughout, after, as well. So real quick, I'm going to cut and paste a URL here, but I just want you to complete this survey, and I'm going to give you about 3 minutes to complete this. And I just have to go ahead and cut and paste the survey link for you into the text chat. So then you have a live link. So it's just a Google form. And I just want to know what sessions you've reviewed already, what exercise you've completed, your experience using R, and if you have any questions that you just want to kind of like formally ask as part of the survey. So I'm going to give you 3 minutes to complete this. So it shouldn't take too long. So get to it, and we'll come back in 3 minutes.
This is Anurag.
Hi, how are you?
I'm good, thank you. I just dialed in.
Oh, great, great. So I don't know if you saw the link above, but if you can fill out this form real quick.
Yeah, I'm just doing that right now.
Perfect. Glad your audio is working. Got 30 more seconds.
Yeah, I already submitted it. If you guys are waiting on me.
Okay, so by this time, hopefully you're just finishing up. And right now, what I'm showing is actually the responses. And I like to kind of share this back with you, just so you have a sense of kind of who's in this session with you. Again, this only represents the 26 people like in the session who've responded, but just so you have a sense of how your classmates have progressed and what their prior experience is compared to yours. So it looks like most people have completed session 1. Thank you. Some people have completed session 2, some are still working on it, and some have actually, haven't completed anything, and a few have completed like sessions like 3 and 4. That's great. So it's important that you have some foundation in R before attending this live session. So you should have R installed in R Studio. I think that goes without saying. If you have questions on those things, please feel free to ask. It doesn't mean that we can't support you and help you get to the point you need to be. But I do want to make sure you're able to practice and use R as part of this session. So which exercises have you completed? So it looks like most people here completed the first exercise. Some are still working on the rest. That's totally fine. These are my kind of favorite metrics. And obviously, as a program in business analytics, it's nice to use data to kind of understand our audience and then build on that. And so it looks like about a third of you are new to coding altogether, which matches the proportion that I saw from the other 2 sessions, because I held 2 sessions before that earlier this week with 20 students, and the other one was with another 12 students. And it was about roughly 30% of people were new to coding. And about half have taken some coding classes, but consider themselves more of a novice in this area. And a little sliver here, one person in this class, watch out, they know enough to be dangerous. And a couple people consider themselves advanced intermediate coding, so that's great. You're going to help us out in the class. And then a few people here are coders by trade and profession. So that's wonderful. That's great. And if we look at prior to this course, your experience with R, we see that in the purple, this class was most people's first introduction to R, and that's why it's designed the way that it is. So it's meant to be accessible at any level, even the novice level. Some people 3 people are familiar with R in the green here, but never used it. 25% have used it a few times, so that's about 7 people in the class. 1 person used DataCamp. That's great, wonderful. I hope my course is better than DataCamp. Just kidding. I hope you learned a lot in DataCamp. And another person actually said that as well. So it looks like no one here is an expert, and I hope that this course will help you develop your expertise. Of course, we know developing expertise doesn't mean taking just one course in something, so it's a process. But luckily, as part of the MSBA program, my course is one of many that you'll be taking that has R programming in it. So you'll also be taking the statistics portion of this course, and then you'll be taking a course in data mining that will have a lot of different R packages that you'll use to interrogate and model and analyze data. And also in my data visualization course that you'll take in Shanghai, we'll be using R to visualize data in a very sophisticated way. So you'll have plenty of opportunities to build on what you learn in this course, which I think is pretty cool. And this is just like a little bit just about the class, like what programming languages do you already know? And we're looking at Google's, responses, which we know that this graph doesn't look that great because I can't read what I have to actually mouse over to show you what the percentages mean. So, so you can see like Python, Java, a couple people, C, C++, JavaScript is kind of on par with Python. SQL seems to be the largest area in which folks have experience. Fortran, Basic, and then some none, SAS, Python, and SQL. Some are just new. Okay, so I hope that's just helpful for you to have a sense of kind of where you are in relation to your peers. And then there are these questions that I will certainly get to. So what I'd like to do now is return back to my slide deck and just tell you a tiny bit about me, since you shared a tiny bit about yourself. So I'm an associate professor here at Stern, and like I said, it's my honor to greet you to this program in a virtual way. I've been teaching in the program ever since it began. So as part of the committee that worked on the curriculum, and have come to teach 2 courses in the program, which is pretty cool. And this course was actually added to the program the second year the program ran, because there is such a demand to not only learn Python, but also to really learn R in a formal way. R is one of the top languages used in business analytics, in addition to Python and SQL. So having this as part of your toolkit is super important. I have a little promo up here. So I'm writing a book, or actually I finished a book on data visualization that's coming out in September. So as part of my class, you'll get a copy. And it has really great case examples about how people use visualization in their practice, not just kind of how to visualize data, because we know we can always get the techniques, but I feel that learning is much more beyond getting the techniques, but understanding how to interpret what happens after you master the techniques. So that output, the results, and then how to communicate those results. Visualization is really key in that. So it's full of case studies and examples, and even ones that are written from MSBA alumni. So that's pretty cool to kind of share how they use data visualization in their business analytics practice. So I hope you have a chance to read that. Well, I know you will as part of my course. I also always like to mention, feel free to connect with me on any social media platform. Some faculty, aren't as open to that. I'm totally open to that. So if you want to connect with me on LinkedIn or Twitter, I frequently post things related to our data visualization or my teaching. My life is kind of a full circle. So I did my undergrad at Stern in information systems, and I'm kind of back at Stern many years later, teaching in the same department with many of the same faculty, actually, that I took as a student, teaching courses in R and data visualization, and a few other business operations courses, some experiential courses as well. In between that time, I was at Columbia University, and I taught programming there. That's actually the first course I ever taught. In 2002 was Java. So I've been teaching programming for, you can do the math, a long time. And it's one of my favorite subjects to teach, especially from the ground up, because it's really interactive, dynamic, and I really focus on a hands-on approach to teaching and learning. Part of the other half of what I do at Stern is I run a learning science group. So learning science is kind of like data science, but it's focused on learning and learning outcomes and learning analytics, and how you design experiences to understand how students are learning and how they're progressing in their work, and finding evidence for that, so you can recommend future and better learning interventions to help create digital experiences and learning experiences for students that are studying business. So I'll talk probably more about that at another time. In my work, I bring in a lot of real companies, and I'm focused on the application of theory to practice. And these are just some companies and organizations that I've worked with in part of my courses. We'll be using real data in my data visualization course that comes from real companies. So that's just a little bit about me. We'll have time, of course, in informal ways to chat more, and I really want to learn more about you. Now, we have a big group today, so this exercise is twofold. I have 2 points to it. So the first point is that I should put my camera on. I would love to first learn a little bit more about you. But there's 30 people, so we don't want everyone going on for like 5 minutes, even though I'd love to learn more about you in a longer way. So if you could just keep it to 10 or 15 seconds, tell me, where you're calling in from, your job title, and of course, who you are. And the second purpose of this is to check to see if your microphone is working. Okay, so then we can communicate. It's a good test for that. And so what I'm going to do is I have a sheet of the 30 people that have signed up, and I'm just going to call your name, and I'm going to start with Kristen because she is the first person, I guess, who signed up for this, or first person on my list. And I'm going to ask you to unmute your microphone and then just kind of answer some of these questions that I posed here.
Okay, hi, can you hear me?
Yeah, hi Kristen, welcome.
Hi, thank you. I'm Kristen Dardia. I'm calling in from Jersey City, New Jersey, and I am a product development manager on a data science team.
Great, well, welcome Kristen.
Thank you.
Next is Now Hero.
Yes, can you hear me?
Yeah, we can, welcome.
Yeah, my name is Naohiro Yoshikawa. I'm calling from Tokyo, Japan, and I work for a consulting company. So, yeah, that's it.
Wonderful. Tokyo is one of my favorite cities.
But it's midnight. I want to sleep.
Next, we have Anna Olson. Anna, are you on the line?
Hello? Yes, I am. Can you hear me?
We can, welcome.
Oh, yes. Well, my name is Anna Olson. I'm calling in from New York City, and I'm a consultant in analytics at Ogilvy One.
Great, welcome. Thank you.
Thank you.
Next, we have Tiago.
Oh, hello.
Hello, hi. Yes.
Yeah, hi there. So actually, my name is Tiago. Okay, I'm from Brazil, and I'm entrepreneur here in the healthcare sector.
Wonderful. Welcome, Tiago.
Thank you.
What time is it in Brazil?
Actually, it's 1:23, 1 p.m.
Okay, so not too bad.
Yeah, not too bad for sure.
Okay, next we have Martin.
Hello, can you hear me?
Yes, we can. Welcome, Martin.
Hi, thank you. My name is Martin. I'm dialing in from San Francisco. I work at Google and a sales team.
Wonderful. Welcome, Martin.
Thank you.
Next, Kurt. Kurt, are you on the line? Okay, so Kurt, looks like we can't hear you, so I'm going to circle back to you, and you can feel free to introduce yourself on the text chat. We'll move on to Mark Weldon. Mark, are you on the line? Okay, then next we'll move on to Janya.
Hi.
Hi.
This is Saujanya, and I'm dialing in from New York City. I work for a retail organization, and I'm into analytics and data science.
Oh, great. Well, welcome.
Thank you.
Next, we have Jerome.
Yep, Jerome here, calling in from Manhattan. I'm a software developer at a clean energy company.
Very cool. Welcome, Jerome.
Thank you.
Next, we have Rebecca.
Hello, this is Rebecca. I'm joining from Singapore, and I also work at Google in sales too.
Oh, cool. Rebecca, what time is it in Singapore?
It's midnight.
Thanks for joining us so late. Matthew Spalding, are you on the line? Looks like you're muted. I'm going to unmute you. We see you, but I can't hear you, Matthew.
Hi, can you hear me?
Yep, got it.
Yeah, hi, sorry about that. I'm Matt Spalding calling from London, England, and I worked previously as a fixed income portfolio manager at Deutsche Bank.
Oh, wonderful. Tell us what time it is in London?
Oh, it's 5:30.
All right. Well, thanks for joining us. Okay, next we have Anurag.
Hi, this is Anurag. Can you guys hear me?
Yeah, welcome.
Thank you. I work for a healthcare company. We make a EMR software, and I'm on the implementation team. So I work at client sites mainly. Currently, I'm in Nashville, Tennessee for the last few months. It's a fun city to be in.
Great, great. Welcome. Next is Molly.
Hello, can you hear me?
Yeah, welcome.
Great. So my name is Molly Tustweed. I'm calling in from Boston. I work at Wayfair currently, and I'm on our competitive intelligence team.
Welcome, Molly. Thanks.
Thank you.
Next is Shangri-La.
Hello, can you hear me?
We can. Welcome.
Yeah, hi everyone. My name is Shangri-La. I'm calling in from Singapore. I work for OCBC Bank in the market price control team.
Great. Welcome. Next is Sheil. Sheil, are you on the line? I see you're here, and I see your mic is enabled. Yeah, starting to hear you. You're a little staticky, Sheil.
Hi, am I audible now?
Yeah, a little bit.
Sorry, I'm on a makeshift mic arrangement today. Okay, so hi, I'm Sheel. I work with Cognizant. I'm an Oracle consultant, and I'm calling in from Pune, India.
Great. Where are you calling in from?
Pune, India.
India. Okay. What time is it in India?
Yeah. It's 10 p.m.
10 p.m. All right. Well, welcome, Sheil. Thanks. Next is Mike Mara.
Let's see. Hi, folks. Can you hear me?
We can.
Excellent. Okay. Hi, Mike Mara here. I'm a business systems and analytics manager for Student Transportation of America. We have locations all over the U.S. and Canada, but I'm based out of Wall Township, New Jersey, so not too far from NYU.
Not too far. Not too far. Welcome, Mike. Next, we have Brock. We see you. We can't hear you, though. Brock, I'm going to unmute you. If you can.
Okay, thanks.
There you go.
Back on it. Hi, I'm Brock. I'm originally from Australia and now living in Western Massachusetts, and I work as a consultant in the asset management industry.
Great. Well, welcome, Brock.
Thanks.
Next, we have Cesar.
Hi, can you hear me?
We can.
I'm Cesar. I'm calling in from São Paulo, and I'm a manager in market intelligence area and economic consultancy.
Wonderful. What time is it in São Paulo?
1:30 p.m.
1:32. Yep. Great. Welcome.
Yeah.
Next is Michelle.
Hi, I'm Michelle. I'm dialing in from New York City, and I'm a consultant for Bank of America Prime Brokerage, and I provide advisory service to hedge funds.
Great. Well, welcome. Thanks for joining us. Next is Nader. Nader, are you on the line? I see that you're here. All right, well, we'll circle back to you. Maybe you work on getting your mic. Next is Anurag.
Did you say Anurag?
I did, yes.
I already did the introduction. We're going again.
Oh, you did. Oh, okay. I'm sorry. Maybe. Oh, because you.
Okay.
I'm sorry. You registered twice on my list. Okay.
Yeah.
Well, nice to hear your voice again. Diego is next.
Hi everyone. Can you hear me?
We can.
Okay. I'm Diego. I'm in New York. I work for Google also in the sales teams.
Wonderful. Wonderful. A few Googlers here. That's great. Next is Robert.
Hi, I'm Robbie Freeman. I live in Brooklyn, New York, and I am the Senior Director of Clinical Operations at the Mount Sinai Health System. I'm also a nurse, but no longer work with patients, work in a leadership capacity.
Wow. Wonderful. Wonderful. Nice to meet you, Robert. Next, Maddie.
Hi, can you hear me?
We can. Welcome.
Thank you. Maddie Benjamin. I'm in New York. I work for Guardian Life Insurance Company. I do digital strategy there, but really I manage the website and all the marketing analytics, and we're putting in a marketing analytics tool. So I want to figure out how to, oh, sorry, I'm not supposed to say that.
I think this program might help you.
Yeah, exactly.
Well, welcome. Next is Matt. Matt Measle.
Hey, Kristen.
I heard you for a second.
Does that work now?
Yes.
Sorry. Okay.
Something happened again. Whatever you did before worked.
Okay, let's try this one more time.
Yep.
Okay, my name is Matt Mizell. I am calling in from Manhattan, where it's 12:30 in the afternoon. I'm a vice president of internal audit for Moody's Corporation.
Oh, wonderful. Wonderful. Well, welcome, Matt. Next, we have Tamara.
Hi, can you hear me?
We can. Welcome.
Okay, thank you. So yeah, my name is Tamara Kempf. I'm in London as well, just like Matt. It's now 5:35 here. I work in enterprise data sales at Bloomberg.
Great. Well, welcome, Tamara. Next is Benson. Benson, are you here? I don't see Benson, so we'll circle back, see if he can get online. Next is Stephanie.
Yeah, hi, my name is Stephanie.
I am dialing in from Amsterdam. I am heading up the business analytics department at Hunkemöller, which is a large lingerie company in Europe.
Oh, wonderful. Well, welcome, Stephanie.
Thank you.
I'm going to circle back to a few people that couldn't talk before. Kurt.
Hello, hi, can you hear me?
We can. Welcome.
I figured out the system.
Nice.
I'm a senior analyst at Con Edison, the utility here in New York.
Welcome. Welcome. I think there's another student from Con Ed in a different group. Welcome. Next, we have Mark Weldon.
Hi, can you hear me?
We can. Welcome, Mark.
Oh, perfect. I'm Mark Weldon from New York City. I work for Guardian Life as well in our broker dealer, and I do business analytics for our broker deal.
Oh, welcome. Thank you. Is there anyone that I missed? Feel free to speak up if you and introduce yourself.
Yeah, good morning, good afternoon, everyone.
Oh, a few of you. Okay.
So good morning, good afternoon, everyone. It's John Kimmett. I'm based in Summit, New Jersey. It's about 30 minutes outside of New York, and I'm the head of strategic planning and decision analysis for Celgene, which is a biotech or a pharma company.
Great. Welcome, John. Thanks. Anyone else?
Marlene De Oliveira. Hi, Marlene here, also based in New York, like many of us. I work at Townhouse, which is an advertising production agency, part of the WPP network, and I'm responsible for client operations.
Well, welcome, Marlene.
And hello, this is Nader speaking. I'm calling in from Dubai. I'm an ex-investment banker, now work in business intelligence and reporting for the Dubai city's Department of Tourism and Commerce Marketing.
Wonderful, wonderful. What time is it in Dubai?
It's just past 8:30 p.m.
8:30 p.m. Well, welcome. Thanks for joining us in the evening. Anyone else? Alrighty. Well, I hope that was useful, just to have a sense of like who you're learning with and who your classmates are, just kind of putting a face or at least a voice with a name and having a sense of where people are studying from and where they're calling in from and what they do. And it's just amazing if you hear, you're listening to all these different amazing roles that your colleagues have in this class. It's a really amazing program to be a part of, and global as well, which is something that we really love about it. That it's not just the networking opportunities are tremendous. Your classmates have a wide variety of experiences, and so really want to give you a warm welcome and thanks so much for taking the time and the patience just to kind of give your attention and hear a little bit about everyone. So now let's get to work. So what I have up here is the roadmap that I put in the introductory materials and also the syllabus, but I like to just bring it up just to orient you. So really by this point, so the pre-module, started March 19th, and between March 19th and 25th, approximately, my recommended schedule was for you to complete, the first 2 lectures, sign up for a web meeting, and then after the web meeting, go ahead and complete exercises 1.2 and 2.2. Some of you done it ahead of time. That's great. You're ahead of schedule. And then after March 25th, start working on lectures 3 and 4. Sign up for the second web meeting where we'll review exclusively those exercises that correspond to lectures 3 and 4. And then by, early April, complete the last 2 video lectures, and then sign up for the last web meeting, and then complete the last 2 homeworks. You can submit the homeworks on a rolling basis, and then our teaching fellow will be able to, he assesses those and gives you feedback within like a week or so. So then you get feedback on a rolling basis, which we think is helpful. And so if there's any misunderstandings early, we can make sure that we catch those and that you don't fall behind. As you know already, this is a very intensive program. We know that you're busy and you're working on other pre-module materials as well. So for the first part, for the R portion of this course, I really want you guys to get it done by like, early April. And then you can focus on applying R to statistics, right? So to be able to use statistical models and implement those in the R programming environment. That's the idea here. So I hope this roadmap's helpful. Let me know if you have questions on this. You can ask those in the text chat, or even there's a hand icon for you to raise your hand if you have a question. I'll look at those as well. And then you can just verbally ask your question. So today we'll be going over exercise 1.1. And if we have time, we'll start exercise 2.2. These materials are posted in the materials section of the GoToMeeting. They're also available on the website that I created for you guys, which was that R Fundamentals website where all the lessons are. I hope that material is helpful. I just built it for this class early January, and using a program called Bookdown, which is actually a package in R that allows you to create literally books with R code in them. And the R code formatted appropriately and gives you a lot of different output functions. And so it's pretty cool to actually create materials in R on R. It's very meta for me. So that was fun. And so I hope you enjoy the materials as well. I also spent many hours in like the studio recording the lectures and doing the code walkthroughs for you. So then you can always go back and hear me work out some problems if that hopefully that's like helpful for a review. I see Nader asked a question in the text chat in terms of, excuse me, I just looking at the text chat about what a tibble is, and I will certainly note that, and I will explain what a tibble is. Just for now, I'll just answer the question briefly. A tibble is simply a data frame or a data structure, and you could think of a tibble as like an Excel spreadsheet, for lack of a better kind of metaphor. So it's a data structure that's organized into rows and columns. And it's the newest type of data structure that's been implemented in R, and that comes from this package called the tidyverse package. And so that's my short answer. So it's a data structure, and it's going to be the data structure that we use that our data will be structured in. So if we import like a CSV file or we connect to a database, usually that data will be in what's called tibble form or data frame. We use those words interchangeably. A tibble is simply an updated data frame. Okay, it's like a more modern one that preserves some of the integrity of the data, where the old version of how you would store data in R would coerce the data, which means it would transform some of the variables into data types that we didn't like, or that were kind of messy. And we will go over that a lot more. But Nader, I hope, does that answer your question at a high level? Okay, cool. So we're going to work on exercise 1.1, but before we work on this exercise together, I just want to highlight two things. One is I'm going to give a quick mini lecture on a few things, just to kind of orient the topics for today. And then I'm going to recommend that you have exercise 1.1 up when we begin to work on it and R Studio, so you kind of can work side by side. And then the third thing I'm going to ask for you to have up is going to be that go to training window, so you can cut and paste your answers in the window as needed. So you'll get used to kind of working in this way, and that's why we spend some time in the first session talking about how we're going to work as well. So let's get started with the basics of the R Studio environment. So at this point, you've installed R, and so that's you have to install the R programming environment, and then you need to install R Studio, which is going to be more of what we call like a WYSIWYG, or a graphical interface to programming in R. It's not that graphical, but it does have some nice features. So I'll just explain a few things about what we're looking at here. So why don't we start with quadrant 1 where it says environment. So here is where we're going to see our different data structures that we've created or imported, like our data, and also any kind of values or variables that we've created. We also have the ability to import data by the press of a button, so we don't always have to write code to import our data. However, we will learn how to write code to import our data as well. Down here, below quadrant 1, we have just where our visualizations will appear. We also have a few other tabs that allow us to get help, export any images that we create in R, like data graphics, allow us to import packages or additional toolkits that we might need. So during the next online session, we'll learn about packages, but they're just basically like extra toolkits. So if there's this really new model that a top researcher at NYU Stern came up with, and they built a package in R to allow you to implement that model, you would be able to then include it or in your version of R and then use it. Okay, you can also build your own packages. So if you've built a few toolkits to do fancy things that you like to do in R, you can also build your own. Up here where it says like session S01 in-class session answers, this is where you can write your R code as programs. For purposes of today, we're going to write all of our code in the console window. So that means we're working with R as a calculator. We're typing something in at this command prompt, and then we are going to press enter and then see the output. So we're just dealing with input and output. And when we deal with input and output, we have the greater than sign here, and that's just representing the command prompt. That's where we start typing at that command prompt. And you can follow along, but you can type 3 plus 2, and then we get an output of 5. We can type 100 divided by 5. We get an output of 20, and so on. 12 plus 12 plus 12, we get an output of 36. So a question for you, who can tell me what the 1 means that's in brackets that we see on each of the output lines? It's the line number. Yeah, Maddie, that's correct. So if I had an output that was many lines long, it would tell me the line number, but also it looks like the line number now, but let's say the first line showed me elements 1 through 10. The next line would actually say 11. So it would tell me that I'm looking at the 11th element. Okay, so here we're looking at the first element. If it was on the first line and there were 10 elements in the first line, it would still say 1. If I go over to a second line, it will tell me what the next element is, or next number, let's say. Okay, so that's just something to note. When you see that, it's not really part of your output. It's just really a guide to help you interpret what you're looking at. So simple stuff, arithmetic operators. You're obviously familiar with these as using R as a calculator, having done the first lesson and having just exposure to basic mathematics. I like to go over this because as a contrast to other types of operators that we're going to be working with. So we have arithmetic operators. We have ones called logical operators. We have ones called assignment operators. So we like to divide them into categories. And part of my purpose is to help you, especially those that are new to coding, not just understand the syntax that like when I want to do addition, I use the plus sign. I mean, that's obvious, but that you know that it's an arithmetic operator. And so knowing that is great because then you're able to describe what's going on. If I use something like not equal, this is an example of a logical operator. So I'm just typing a few of the operators in the text chat. Okay. And if I use something like equals, that can be an assignment operator. Or less than minus, that's also an assignment operator. But if I just say greater than, that's a logical operator. So there's lots of different types. And so right now it's on the screen: arithmetic operators, addition, subtraction, division. Multiplication, we use the asterisk. We don't use the X, okay? For exponents, we use the caret, which is above the number 6. Okay, so raising 2 to the 3rd power, for instance. And if we ever want to know what the remainder is when we're doing division, we can use something called a modulus, and that's a double percent sign. I like to show that. It might not be immediately useful to you now, but I like to show just the range of some arithmetic operators. These are not all of them, but these are some key ones that you'd be using. So next, I want to talk about variables and assignment of variables. So in this statement that's written here, I just want to talk through how you would read this. So you read it as the value of 3 is referenced in the variable x. And even though it looks like x is less than -3, it does not say that. Okay, so it's this combination of less than minus is the assignment operator. It allows you to reference values in a variable. So I have this annotated. So the name of the variable is x. You can call it peanuts, okay, or pineapples. You can call it x or y. There are a few things you can't call it, and there's a number of reserved words in R. So you can't call it pi because pi, pi, is already taken as a reserved word and variable in R. But you probably won't run into that too often in terms of using reserved words. And then we have our assignment operator, and then we have the value that's going to be referenced in the variable x. Okay, so you can go ahead in RStudio and type this in, just assign the value of 3 to a variable x. And while you're doing that, just want to know that there's another way to assign values to variables, and that's using an equals operator. Now, those of you who, when you answer the survey said that you have prior programming experience, probably, almost definitely, you think of assignment as using the equal sign. You can use the equal sign in R. However, the culture and the community of R coders and developers strictly use the R assignment operator, which is less than minus sign combination. So I would suggest that you use this throughout your coding, even if you're familiar with using the equal sign. For those of you that haven't coded before and don't have that reference, all the better, because R makes it a little confusing. When you're in Python, though, you're going to be assigning variables using the equal sign. So when you're taking Panos' class, the assignment is going to be slightly different. But it's really no big deal. You just have to get used to it. And a point that I want to make is, well, why not just use the equal sign since it's possible? Well, you can. However, when you read the documentation, all the documentation will be written using an assignment operator of the less than minus sign. So I hope that's clear. But if you have questions, feel free to ask them in the text chat, raise your hand. So now I'd like you to create a variable named Wyatt and assign it a value of 42. So you can do that right in your console window. And once you've done that, it's going to look something like this, right? And to access that value, you can just literally type in Y, and it will return. That's the word we use. It will return an output of 42. Okay. Further examples, obviously, we can add. Now that we have a variable created, we can manipulate it. So I can add 2 to Y. So what's the value of Y at this point after I add 2 to it? You can just type it in the text chat. So I'm looking at my first line of code. Some people say 42, some people say 44. So I haven't updated my variable. I'm just doing math and using it as a calculator, but nothing's stored. So in this first line, I say Y plus 2, and the output's 44. But if I typed in Y again, it would say 42 because I haven't updated the variable. We haven't talked about that yet. Okay, I'm using y as if it was 42, and I can't go back, and it's not updating it. Okay, obviously I can square y, and that's how I use the exponent function to get that output. So you can try this out as an example. The great thing in programming is that you can actually prove, right? So when I say that y hasn't been updated, you can go ahead and type y and notice that it hasn't been updated and see that for yourself. So let's do this again. Assign the value of 42 to y, and then we're going to read this from right to left. Then subtract y minus 1, and then reassign it using the assignment operator back to y. So then at this point, y will be 41, excuse me, right? Because I've updated the variable. Not I'm doing mathematics, but now my sophisticated computation is now the output of that is stored in y. If I print that out, I could either type y or I can use a function called print to print it out. I show you I could talk about the spacing. Sure, Kurt. Actually, I did a fun blog post on the spacing, but just like for a minute. For instance, like if I say this statement here, which says I'm assigning the value of 1 to x, that means x is 1. If I say something like this, it's different. It's saying x, it's asking the question, is x less than -1? So spacing makes a difference. And you can try this example out that I wrote in the text chat by using spacing. So for the assignment operator, those two characters need to be right next to each other. No space in between. Good question, Kurt. So then this is another example for you to try. Assign a value of 42 to a variable y and assign that value to x. Okay, so we're assigning our value of 42 to y, and then we're doing what's called variable reassignment. Now x and y are equal at this point. If you want to test to see if they're equal, if you don't believe me, what would you do to test this out? Anybody know? You can type your response in the text chat or just say it. Maddie's got it. So is Molly. Sorry, you're writing too fast. A lot of people got it right. So now I'd use a double equal sign. And so and the double equal sign is an example of what kind of operator? You can type that in. Great, a logical operator. And a logical operator is going to return what kind of value? True or false? It's going to return a logical value. Great. So if anybody didn't get that, my question was, how would I test to see if x and y are equal? Because look, I've assigned 42 to y, and now I've assigned y, which at this point in time is 42, to x. So then in the text chat, I just wrote x equals y, and that should return a value of true, all caps. Because I'm using a logical operator, which is the double equal sign, which does a test for equality. And it essentially asks the question, is x equal to y? It's testing for truth. If it is, it returns true. If it's not, you can guess that it returns false. Good. Many different data types and structures. We talked about a few of them. By default, anytime you create a variable in R that has a number, whether the number is 32 or 3.14, it's going to be a numeric. Okay, that's going to be the data type. If you specify what you want the data type to be, you have many options. We can choose integers. We can choose Boolean. We can choose characters, many different data types. And we care about data types because we don't just use R to create variables. We want to manipulate variables, and we want to work with data and be able to manipulate data, analyze it, model it, and we need to know the format of what those rows and columns are in our, let's say, for lack of a better example, our Excel spreadsheet. So just to think about the types of numbers that can be of type numeric, we can have integers, which are whole, positive or negative numbers. So -4 or +5 are examples of integers. A float or floating point decimals as any number, positive or negative, that has numbers after the decimal point. We can create not just single values, but vectors, so multiple values in a single variable called vectors. We can think of a vector. Let me give you just a quick example of a vector. A vector is a column in Excel. So anytime I say vector, just think of one column. It's a variable with multiple values or multiple elements. Other data types and structures, Boolean, we talked about that. That's logical. That's our logical data type, true or false. Anytime we use words or use double quotes around any value, it's considered a character, like hello world or your name. And we can also have more than one value stored in a variable that's a character. We can have character vectors, of course. So a vector is a data type. Character, Boolean, numeric, those are examples of data types. Here's a list of some data types in R that we just went over. So when I say Boolean, I mean logical. So we can have numerics, we can have characters, logical, integers, factors, which you will, lesson 2, you'll go over factors. A data frame is an example of a data structure, and a matrix is also an example of a data structure. What's the difference between a data type and a data structure? Data structure is kind of the format of your data, and a data type is the type of value that the data is in, numeric character. Sometimes things, though, look like numbers, but are really characters. So in the text chat, for instance, I can have, if I say grade is 98, this is a character. Grade is a character. You can prove that. So if you just typed in what I typed in the text chat into R, and you use a function called isCharacter, you say is.character, you see that's that second line right here, and you pass in grade, it's going to return what? Let me know if you did it. True. Meaning that grade is a character, not a numeric. If I did is numeric and I wrote grade, that would return false. Okay? So here I have it's a table that gives me the data type or data structure, a function to check what my data is, and if I need to change it, I'm giving you functions that show you how to change it. So I can change grade to a numeric, and I can do that by simply saying grade, okay, stay with me, as.numeric, and I can pass in grade. So I'm using a function to convert my grade, which originally was a data type of, we know has a value of 99, but was considered a character because I had double quotes around it. And then I'm reassigning it back to grade. And then you can say something like is.numeric and pass in grade. So basically here you're just proving out the work that you're doing. So let's walk through a quick example. So here I'm using a function called class. Class is a way to find out what data type it is. So instead of saying is numeric, is character, is matrix, is data frame, I can just say class, pass in whatever I want to interrogate, which in this case was X, and it returns the data type. So in this case, x is a numeric. If I assign the value of 1.2 to z, and I check the class of that or the data type using the class function, you'll see that it's of type numeric. Okay, even though it's a floating point, right? Because generally R always, any number, it's gonna by default give it a data type of numeric, unless I put double quotes around it, then it's gonna give me a character. Any questions on this point? Let me know if I'm going too fast or too slow. You can even send that to me privately, or if it's just right. I always like to get that feedback. So I'm creating a character. It's called book, and I'm assigning that to a value of B. If I type B, my output will be book. And what do you think is happening on this line that I'm mousing over, where it says find out data type? That's a comment. Nice. So Jana, thank you. Mike, yep. Maddie, thanks. So this is just notes to myself in English to kind of say what I'm doing, okay? And I use the pound sign for this to write what's called comments. It's always great to comment our code so we remember what certain functions do, especially as we're learning things. So I put a comment here, and then I say class B because I'm trying to find out what? I'm trying to find out the data type for B, and we can see its character. So I mentioned something earlier. It was called vectors, and I described it as a data structure. And so this is where we can have a variable that contains many elements. And again, thinking of a vector as a column in Excel is a great way to think about it. And how I create a vector. So we're not yet at the point of like importing data or accessing data via databases. We're just kind of creating all of our data by hand right now as a mode of learning. So now I want to create like a column that looks like a column in Excel. So to do that, I need to use the combine function. That's C. That's what I have highlighted here. And so I use a function C, and then in parentheses, because every function you can kind of spot them because they always have parentheses. It's always like usually a name or a letter and then parentheses. And what you pass into the parentheses are called parameters. And so in the combine functions, it takes the parameters of the data that you want to create in a vector. So here I'm creating a 6-element vector. This is element 1, 2, 3, 4, 5, and 6. Okay, of values 1, 2, 3, 4, 5, and 9. So I create that vector x. Now notice I'm using x and I keep updating x. X is no longer what it was before, whether it was 42, right? So I'm reusing that variable, that number 42 that I had stored it referenced in it before is completely gone. It's now replaced with a vector of 6 elements. And now I can even do math on a vector. So I can add 2 to every value in the vector. So I say x plus 2, it means basically 2 plus 1, and then it returns 3. 2 plus 2, it returns 4. 2 plus 3, 5. 2 plus 4, 6, and so on. We use C to create vectors, Diego. So now go ahead and create a vector called months with the integers 1 through 12 and square that vector. A short assignment for you. I'll give you like 20, 30 seconds. Okay, and when you have that, you can type your answer in the text chat. Cut and paste it. You shouldn't have to type it. Looking good. Some people just put the answer, some people put the whole thing. That's great. So a couple ways we can do this. two ways. So one is that we can use the combine function and then type 1 through 12 elements, and then assign that to months. Or I could say 1 through 12 inclusive using this colon. Okay, so this operator allows me to to give the range, and by default the range will be 1 through 12 inclusive. Those values will be then assigned as a vector to months. And I don't even have to use the C or parentheses here. This is kind of a shortcut. Okay, that's the alternative, and that's why I put ALT here. Alternative way to solve that, and you can try that out yourself. And then obviously to square that. Good. So now create a vector called days with the days Monday through Wednesday. Mike, I'd like you to submit both. Okay, so if you've done that, type your answers in the text chat, and it should look something like this, right? So the key is not to forget the double quotes around the days of the week, and to use the combine function. Nice, thank you. So functions obviously are analogous to the functions that you've learned in your calc classes. They operate on some specified arguments and generally return some value, a number, a string, etc. So we use the word string kind of interchangeably for the word character. And so a string is anything that's in double quotes, like Monday or Tuesday or Wednesday, for example. Some functions are built into R. We've been using ones already. Here are a few that to introduce you to. So square root function. So instead of having a arithmetic operator, we have a function for the square root. To take the mean, we can obviously always calculate the mean by hand and even write code to calculate the mean kind of long form. But the short form way is to use a function called mean. And I want to just speak to this line for a second. So notice I'm using the combine function and I'm creating 5 elements, okay, as a vector. And then I'm passing that into a function called mean. So this is a function within a function. And so this is generally how we code. It's kind of a shortcut. So first I can create the vector, then I can pass the vector in. There's many different ways you can approach doing this, but this is a function within a function. And then I get my output of that. If I wanted to convert, let's say, a string or characters to uppercase, I can use a function called toUpper. Just some other examples. So at this point, I want to direct your attention to exercise 1.1. And all the exercises that end in 1, like 1.1, 2.1, 3.1, are the ones that we will go over in these online sessions. And the ones for homework are the ones that end in 2, 1.2, 2.2, 3.2, etc. Any questions at this point before we kind of dive in? So I'll give you a minute for questions, and my directions for you are to make sure you have RStudio open, find the exercise, okay? And again, you can go to the materials tab just for a quick reference and click literally on exercise 1.1. Okay, so I've just done that. So you can see the exercise. We're going to work through these problems. And I'm gonna ask that you go ahead and start working on questions 1 through 4. And as you finish those, just cut and paste your answers into the text chat. And then I'm going to bring up RStudio and go through these with you as well. So Maddie's question is, do we need to hand in the point ones? No, you do not. Merely to practice. as an aside, you'll also notice, if I can scroll down here, that there's even a lesson number 7 or chapter 7 here. Just trying to get to it. I'm not able to scroll. So I have something on advanced SQL and R. So I'll be adding advanced exercises as well that you do not have to do, but just more for funsies. Okay, I'm going to bring up my RStudio now and work along with you. If your preference is to kind of follow me, that's fine, instead of solve it on your own. But so I'm in my environment. I'm going to clear my console window just by pressing Control L. And I've brought up my exercises, which I have already stored. And the first one is all about, and I'm typing in my console window here, it's all about making sure that we use the, instead of the X for multiplication, the asterisk, and following the order of operations. If you did this one, relatively simple, you should get 130.5769. Let's say if you want to round that to 2 decimal places, you could even use a function called round and pass in that whole equation and separate it by a comma, add 2, and I'm saying round to 2 decimal places. So getting some more practice using functions and exposure to different types of functions. The second question asks for the absolute value of -88. We know what the answer is going to be. We know the answer is going to be positive 88 when we take the absolute value of something, but knowing that there's a function called absolute value is helpful. It'll be helpful for one of the exercises down the road. And also, when we're looking for change in things, sometimes we don't want negative numbers, and so that's why we take the absolute value. If we didn't know what ABS meant, and we just saw it written in like my code or your code somewhere, you could always say question mark ABS parens, and that will bring up the help file in the on the right-hand side of the screen, and it will give us information about ABS, about what it is, and it'll also show you how to use it. Okay, and so this is under miscellaneous math functions as part of what we call base R, or your pre-installed R. Good. So same thing too. I'm asking you to take the base 10 logarithm of the number 72. And so that will come out to 1.857332. But if you didn't know what that function did, you could always type log 10, question mark log 10, and learn more about that function. Okay. You could even, if you really wanted to, check your work as well. So the next question, we're in question number 4. So we're going to compute the exponential function of 1.45 minus 2.612. So here we're using the exponential function, or Euler's number, minus 2.612 to get 165. So you can, again, exp question mark, we can learn more about that function. Okay, so next, this is just a simple age computation to figure out if you're old enough to vote in the US. So I'm going to clear my screen in the console window. I press Control L. And of course, so it's good to start by creating variables. So create a variable for the year born, create another variable for the year current, and then you want to subtract those 2 variables and store those in a variable of age. And then what do you want to do? You want to evaluate whether age is greater than or equal to 18, and that should come out to be true. Okay, so again, practice in kind of your variable assignment and then your variable, evaluation of variables using a logical operator and getting output that's expected. I like to work with problems in which you know what the output's going to be, so then the functions become transparent of what they're doing. So we're going to compute the radius of a circle in question 6. And we're given some information, we're given the area. So we know that if we're given the area of a circle, computing the radius, we need to use our formula where we're taking the square root of the area of a circle divided by pi. So pi is that reserved variable that I mentioned earlier. And we're going to assign that to r. And then how do we see the output of that? Well, we can just type r. It should be 5.641896. Good. Sanajava, what's the max length of a variable name? That's a very good question. I say test it out. We could do a little research on that. We don't want variable names that are that long. A few things. So I'm going to clear my console. We don't want variable names that are like, this is my awesome variable. Right, we wouldn't want a variable that's like very, very long. Could I create a variable that's this long? There's problems with it, right? So you can't use certain characters when creating variables. So we want to keep our variable length to something reasonable, like 7 or 8 characters is reasonable. And because we're going to make mistakes and typos, it'll go off on different lines. So good question. So Kurt, you're saying, how would you review the components of age, which is based on multiple variables? I think, can you re-ask that question in a different way? I'm not sure I understand it. Yep, go ahead. I'm not hearing anything though.
Hello, can you hear me?
Yep.
So I mean, in the sense that it's made up of the year born and year current, how would you be able to see those two elements other than if I put age, it's just going to give me the result of the calculation?
Age just gives me the result of the calculation, right?
But if I wanted to say it's a week later and I wanted to go back and see what is age made up of, being year born, year current.
Right. Well, then you'd be going back to your code. Okay, so we're writing in real time. So once you close down R, like these variables aren't going to be accessible. When you get to session 3, you'll be writing things like up here where I'm scrolling. This is all pre-written, right? So this is just so I don't make like typos and waste your time. But I would be able to go back to my code and then see that, right? Now, what's wrong with this problem is that I should probably use date of birth and current date to get the most accurate age, right? But this is just, like a simple example here. But that's what you would go back to your code and you'd say, oh, that's what makes up age. Is that clear?
Thank you.
Yeah, sure.
Yeah.
Okay, so our next example is a simple tip calculator. You'll do one of these in Panos' class too. It's just like classic programming stuff. That's just fun problems. But again, just practice in variable assignment and some simple computations. So we have a bill. We went out to eat. Our bill is $45.90. So let's assign that to a variable bill. We need to compute the subtotal and the tip. So the subtotal is going to include not only our bill, but also our tax rate. So I've created a variable for bill, a variable for tax rate. Now I've created a variable for subtotal, where I'm just multiplying that times 1 plus the tax rate divided by 100. And then I can just simply type subtotal, right, and get my subtotal. I could take that and I could use the round function, right, if I wanted to, but really don't want to be rounding yet because we haven't added the tip. So why don't we go ahead and work on the tip part of this problem. Let's compute the 15% tip. Here, again, just creating a variable called tip 15 and multiplying the subtotal times 1.15. Okay, and then we can, of course, this is an appropriate time to use the round function to get the final total, including the tip and tax, at a 15% tip rate. We can do the same thing with a 20% tip. Okay, I'm just checking the text chat, just seeing if anybody has questions. So here I am simply doing the same kind of computation I did for the 15% tip, but for 20%, and then I can go ahead and round that. So again, just a simple example. One last thing that is going to be helpful for you to understand as you go forward in working on lessons 3 and 4 is about how to import data. And in exercise 2.1, I ask you to download a data set called winterolympics.csv. So this is the medal count, gold, silver, and bronze medal count for all the countries that participated in the 2014 Winter Olympics, right? So it's old data, and I use the old data on purpose because I want to encourage you to go check out the 2018 data. That's posted on the medal count and rework these problems. But in the meantime, if you have that file downloaded, I just want to walk through about how to import the data into your into R, and then we will. This will be take about a minute. So what I like to do is just go ahead and make sure that you have your global environment window maximized, and you go ahead and click on Import Dataset. And you have two choices, from text base or from text read R. Okay, if you've installed the newest versions, you should have both these options. I'd like you to install it from text read R. And this is going to import my data set as a data structure that's called a Tibble data frame. So back to that original question that came up earlier today. So I'm here, I can go browse to it should take me to kind of my working directory or wherever my winterolympics.csv file lives. That's where you want to navigate to. You choose it. Please make sure you haven't opened this already in Excel or resaved it or anything. Just download it in its native format. Say open. And then you get a preview. And you'll notice that really nice things happen. You get a preview of the data, every column. So there's going to be 7 columns. You see what the names of the data are, these data, and rank, we can see the data type, it's an integer, right? So it's not that default numeric, it's now an integer. NOC means name of country, and that's a character. Gold, which is gold medals, integer, and so on. You have the ability to change the name of your data structure, which in this case is we're importing our data set, and our data structure is known as a Tibble data frame, T-I-B-B-L-E, and data frame. And I'm just going to name this data for now, just to keep it lowercase. Variables is good when you name them lowercase. And then I'm going to keep everything else as the default. First row is names. All that means is that the first row of data represents the names of the variables. So each column we can think of as a vector, right? And this is a data structure that's holding 7 vectors right now for us of different types. So I got integers, I have characters, I have more integers and another character. And at this point, I import the data by pressing the import button. and it launches up here a preview of that data, which is great. And then it did that by executing a command called view data. Now, anytime I want to look or reference that data, I can just type in data, and that will show me the data that I just imported, and then I can do stuff with it. Okay, so I can look at the DIM, which show me the dimensions of the data, how many rows and columns. And there's many other functions that I can begin using to work with my data now that I've imported. So I just wanted to give you that, that walkthrough of how to import data in R. You can certainly import it by writing code by hand as well, and you'll be working to do that. But this is the first step into getting a spreadsheet into R and then begin manipulating it. So at this point, I wanted to just pause to see if there are questions and let you know that we're at our time. So if you need to leave, that's fine. I hope this was really, really helpful in giving you like an orientation to R and working through some basics as a foundation. Matt, so right now we're not saving any of our work, but if we wanted to, we would say file, new file, like R script, and we could type our code here. So instead I would say, maybe if I want to type the dim command, I would say dim data, and I'm not executing it yet, but I'm working to, write my code out. Maybe I want to say something like mean, the mean number of, gold medals. And that would be another, and then I could decide at whatever point in time to run this. Make sure I highlight it, run it, and then it executes it. But I have it saved as I save my file, and I'll call this as my first R script. Okay, and then I can access that, open that at any time I want, and then be able to use these functions. Is that helpful, Matt? Great. Any other questions? You can save the entire R session by just saying, when you exit, quit session, and then it will ask you, it'll prompt you to save it. Glad it was helpful, Anna. Thank you for coming. See you next time. So I'll stick around for a little bit and see if other people have questions, but thank you. How do I remove or delete vectors? That's a good question. I'm gonna have to share my screen again. There's a few ways to, and I don't know if you mean just remove vectors or remove variables. There is a few things that you can do to remove them. But the one thing that we do is we press this broom up here, and I don't know if you can see, I might have to, yeah, you can see it. If you press this broom up here, we're just right next to import data set, that will clear your global environment. Okay, so you can just click this and that will remove every object that you created. So that's a way to kind of clear everything out. another option. I'm not going to remove my variables actually, but another option would be to use the RM command at the command prompt. Yeah, Stephanie, I just got your private text. So if you can exercises 1 and 1.2 and 2.2, you can just cut and paste your like input output as a Word doc. Getting back to another question I just saw pop up. All right, at times the console gets stuck with incomplete code and shows the command prompt how to exit the complete code. Well, I mean, you can, yeah, escape, Anna, that's exactly, you can press escape. So do you mean like this happens? Like you get a plus to keep working? And there you can press escape. Like, so if I'm not done with a function, if I start typing, you know, like round, and I don't put the other paren there, so I haven't finished doing anything, I can press escape. If you're feeling like you're running out of room, it just might be the sizing of your console window. So sizing makes a difference. Oh, excuse me. So to the person who asked me about removing variables, I'm just showing you how to use the RM function to remove specific values of variables. These are great questions today. Woohoo! I wrote a little blog post on like questions that I'm getting from all the groups, and so I'll send that around with a video recording of this session. The blog post will probably take me a little longer, but the other thing should happen the next day or so. Clearing your window, Control L, FYI. All right, I'm just seeing if there's any more questions. There's something about spool. Oh, Shield's asking, do we take all the spool from the console and submit for exercises? I mean, I just want the input and output. If you're like viewing the data, I don't need to see all the data that you're viewing, but just like the input and the output is acceptable. While I'm waiting for any other questions, I'm going to write down some good questions that I want to make sure everybody has. So okay, good, thank you. Oh, Nate, are you still online? I see that you asked something about the escape key.
Yeah, I missed the question about the escape key. What was it for?
Okay, so let's say I'm typing a function, right? Just I'll demo it. So I'm saying round, and I want to pass in some value, but I don't finish my statement. I just say round, and I'm forgetting the paren, right? And I press enter. See how there's a plus? And you're like, what am I supposed to do now? How do I get back to the command prompt? So you just press the escape key, and it gives you the command prompt.
Okay, that's clear. Thank you for that.
Sure. You're welcome. Take care. Okay, it doesn't look like there's any more questions, so I'll stay on for like 10 more seconds. Let me know if you do, but thank you. Have a good weekend, have a good day or night, or both, and see you next time.